Okay, when I went back to look at where we stopped, it looked like the last part of this question got cut off. And so I'm going to do part of it again. We already did the increasing, and we talked about that we're looking at the x values. For decreasing, we have two different spots that we're decreasing. We have this portion of the graph that's decreasing and this portion of the graph that's decreasing. And again, we are focusing on the x values. So here, when we talk about the end of this graph, it is this direction. So we are going from negative infinity all the way to the x value of this point right here, and that's -1. So we are decreasing from negative infinity to -1, and then we are decreasing again starting from this point. And so our x value at that point is 3, and it goes to positive infinity. Okay? And now for our constant, we are looking at where there is no change, that where we stay. Okay, and again, we're just focusing on those x values, and the x values from those 2 points right there is -1 to +2, and that is our constant part of our graph. So when we are talking about increasing, decreasing, and constant, we are looking at our input, our x values. Now for part 2 of this question, we are focused on range. Range is when we focus on our y values. And if you look at the graph, so we're looking at the y values for our graph. Our graph continues to go up. So our y values would continue to go up in the negative infinity direction. Our y values would continue to go down in our positive infinity direction. So our range for this particular graph is negative infinity to infinity. And those are our y values in this graph. Okay, so let's move on to the next question. So we are on question number 17. And question 17 is asking us to find the zeros for this graph. When we talk about zeros, we're talking about where the graph crosses the x-axis or where our y value is 0. So for this function, f of x, we're going to remove the f of x and we're going to put a 0 in there. And then we've got x squared plus 4x minus 45. And so in order to solve this, we have to factor it. And so we've got x, we're going to have an x here. And what we need is we need two numbers multiplied together that give us -45 and added together give us +4. Now because our 45 is negative, that means that one of our numbers is going to be positive and one of our numbers is going to be a negative. The only way to get a negative product is to have one negative number and one positive number. Now, because our sum is positive, that means our higher absolute value number is going to be positive. So in this situation, 9 times -5 is going to give us -45, and 9 plus -5 is going to give us +4. So we set each one of these factors equal to 0, and then we solve. So our zeros, or our solutions to this, are -9 and +5. Now for this one, our first step is setting it equal to 0. Okay, we factor out the common factor and we're left with x squared minus 100. That is a difference of perfect squares. And so we've got x plus 10 and x minus 10. We set each factor equal to 0. And so our zeros for this function, and that means where it crosses the x-axis, it crosses at 0, it crosses at -10, and it crosses at +10. Okay, so that is number 17. For number 18, So our next one is asking us to find all values of x for which f of x equals g of x. So what we do for number 18 is we set the two functions equal to each other, and then we solve. Because this is a quadratic, and we know that it's a quadratic because our x is raised to the second power, we have to solve it by setting it equal to 0. So so I can really move things either direction. I'm actually going to subtract 2 from both sides. And then I'm left with negative x squared equals x minus 12. And now I'm going to add x squared to both sides. And the reason that I did it that way is because now the coefficient associated with my x squared is positive. And that makes it really makes it easier to factor if that coefficient is positive 1 instead of negative 1. So again, I'm factoring. I have one positive number and one negative number. And I know that because my product is negative. The sum of my two numbers is going to be positive 1. So I am going to have negative 3 and positive 4. Negative 3 times positive 4 is negative 12. Negative 3 plus positive 4 is positive 1. So I am going to set each one of these equal to 0. And I get x equals 3 and x equals negative 4. And so that is the values where g of x and f of x equal each other. Okay, so number 19 is asking us to take a parent function. It looks like we're graphing these. I didn't leave enough room for us to graph these. It says write a formula that would achieve the desired transformation of the given function. And so this isn't asking us to graph. So I apologize. We don't need to graph this. So this is number 19. We are going to take our parabola, which is x to the third. That's our parent function. So here's our parent function. We are going to shift it left 2 units, and then we are going down 7 units. So when we are talking about our right and left, what we have to do with that is we have to include it inside the parentheses of our x to the third. So I am going to have x, and I'm going to have some either plus or minus 2, and then it's going to be to the third power. Now, when we are moving things left to right, in general, when we are moving something to the left, we are moving it in a negative direction. But our x to y movement, our x movement, our left to right movement, is opposite in value. So because we want it to go left, which is traditionally negative, we are going to have the opposite there. So it's opposite in value when we move left to right. Now, we want to go down 7 units. So that is an up and down movement, and that is always true to value. And so we would write that as negative 7. So our left to right movement is opposite in value. Our up and down movement is true to value. So this is f of x equals x plus 2 cubed minus 7. And our parent function here is x cubed. Now, for this one, for part 2, our parent function is the square root of x. So we're going to start with the square root of x. Now we want to move this right 3 units. And anytime we go right to left, we are opposite value. So since we want to go right 3 units, we're going to have subtract. And that's going to go inside my radical or my square root sign. Okay? Then I want to reflect it about the x-axis. So I'm going to flip it. I'm going to make it upside down with my x-axis. So my negative is then going to go away from my x. It's going outside my square root. So my negative for reflecting it about the x-axis goes outside. If I was reflecting it across the y-axis, then it would go inside. But because I'm reflecting across the x-axis, it goes outside. And then I want to shift up 4 units. So up and down is true to value, and it goes outside the radical sign. So this one is f of x equals negative square root of x minus 3 and then plus 4. Now, as I said earlier, we are not going to focus on stretching and shrinking. You only need to be aware of how to do reflections across the x and the y axis and move your graph up and down or right to left. So you don't have to worry about part 3 of that. Okay. Now, number 20 is asking us to name the parent function, describe the transformation that has taken place, and then graph that function. So in this one right here, we are going to focus on the plus 4 and the minus 3. And so the parent function is a quadratic or a parabola because we've got the squared. So our parent function here, I'm going to do parent function. Our parent function is x squared. Okay? And our parent function, so let me go ahead and draw my x and my y axis. Okay. So my parent function is going to be kind of, whoops. It's going to look similar to this. This is definitely not perfect. I'm just sketching. So that's my parent function. Now, remember when we are inside the parentheses with the x, we are opposite in value. So this is going to move to the left 4 units. And that is like negative. Okay, so our vertex is going to move to the left 4 units, and then we are going to move down 3. So we're moving to the left 4 and down 3. Okay, so our vertex was at 0, 0. Okay, so our new vertex is going to be negative 4, negative 3, which is going to be about right there. And so let me do that in a different color so that we can compare the two. And this is a sketch. So all this is a sketch. And so it's going to look something like this right here. Okay, so we've moved to the left 4 and then down 3 units. Okay, so instead of having our vertex at 0, 0, our vertex is now, the vertex of the parabola is now negative 4, negative 3. Okay, now our second one, f of x equals negative absolute value of x plus 1. Our parent function for this one is, parent function is the absolute value of x. Parent function is the absolute value of x. Okay, and if we were to draw a graph of what the absolute value of x looks like, and this is just a rough sketch, what the absolute value of x looks like a V. A parabola looks like a U. Absolute value looks like a V. Now, what is happening here, our parent function, or our original, is f of x equals negative absolute value of x plus 1. So what's happening here is we are reflecting this across the x-axis, so we're flipping it, and then we are moving it up 1. So our vertex is going to go from 0, 0. It's going to go to right here at 0, positive 1. And then our new one, and let me do that in a different color so that we can look at the two different graphs. Our new function is going to look like the green. So we have turned it upside down and we have moved it up 1. And so those are all transformations. And for your test, you need to focus on right, left, up and down movement and reflections across the x-axis and the y-axis. So be sure you are familiar with that. Number 3 on this is stretching and shrinking, and we are not going to worry about that for this test. Okay, let's move on to number 21. Okay. For number 21, we are adding, subtracting, and multiplying and dividing these two functions. So our first one is f plus g of x. And what that means is f of x plus g of x. So we are just adding these two functions together. So f of x is 2x cubed minus 6x plus 4. And we are adding to that 7x minus 2. Okay? Now, there's nothing inside the parentheses that can be simplified. There's nothing outside the parentheses that needs to be distributed. So at this point, we can rewrite these two expressions without our parentheses. Okay? And so now we combine like terms. So I have 2x to the third, because there's no other x to the thirds that need to be combined. Then I have negative 6x and positive 7x. That simplifies to just x. Now you can write x or you can write 1x. Either way is completely fine. Then we have 4 and we have negative 2. So that is going to be plus 2. So f plus g of x is 2x to the third plus x plus 2. Okay? Now, just for the sake of space, I probably need to erase this because I did not account for enough space on this. So I'm going to erase this right now, and then we're going to do f minus g of x. Okay? So we are doing f minus g of x. And what that means is f of x minus g of x. Okay, so f of x is 2x to the third minus 6x plus 4. And we are subtracting g of x, which is 7x minus 2. Now, the mistake that students make here is they forget to distribute their negative sign. So our first trinomial, we don't have anything that we can simplify inside the parentheses, and we don't have anything outside the parentheses that needs to be distributed. So I'm going to rewrite 2x to the third minus 6x plus 4. Now, here, we need to distribute this negative to the 7x, and we need to distribute the negative to negative 2. And that's where students make mistakes. They forget to distribute it to both. So it's minus 7x plus 2. So if you're going to make a mistake, that's where it's going to be, is that negative negative becomes a positive 2. Okay, so we have 2x to the third, and then we have negative 6x and minus 7x. That's going to give us negative 13x. Then I have positive 4 and positive 2, and so that's going to give me positive 6. So f minus g of x is going to be 2x to the third minus 13x plus 6. Okay. Next, we are going to multiply, so I'm going to go ahead and erase this so we can do f times g of x. Okay. Okay. So now I have f times g of x, and what that means is f of x times g of x. So we have 2x to the third minus 6x plus 4, and we are multiplying that times 7x minus 2. Okay, so now what we have to do is we have a trinomial times a binomial. So in order to do this, we have to multiply 2x to the third times 7x and negative 2x. So I have 2x to the third times 7x. That is going to give me 14x to the fourth. Then I have 2x to the third times negative 2. So that's going to give me negative 4x to the third. Now, the next thing that I'm going to do is I am going to multiply negative 6x times 7x and negative 6x times negative 2. So when I do that, negative 6x times positive 7x is going to give me negative 42x squared. Negative 6x times negative 2 is going to give me positive 12x. Okay? The last thing I need to do is I need to multiply 4 times 7x and 4 times negative 2. So 4 times 7x is going to give me 28x. 4 times negative 2 is going to give me negative 8. So now I need to combine like terms. I do not have anything else to the fourth power, so my 14x to the fourth just stays as 14x to the fourth. Then I have x to the third, so I look to make sure I don't have any other x to the third, and I don't, so then I'm left with minus 4x to the third, so 14x to the fourth, negative 4x to the third. I actually do not have any x squares to combine with my negative 42x squared, but I do have some x's. So I have 12x and I have 28x, and so that does give me 40x minus 8. Okay, so f times g of x is 14x to the fourth minus 4x to the third minus 42x squared plus 40x minus 8. Okay, now all of the other ones that we've done up until this has been, our domain has been negative infinity to positive infinity, or all real numbers. Okay, now we're going to look at one where our domain is no longer our real numbers because we're going to have something in the denominator. So I need to erase our multiplication of our two functions. So I'm erasing all this. And now we're going to focus on the division. And when I have f divided by g of x, what that means is f of x over g of x. And when I have that, that turns into 2x to the third minus 6x plus 4 over 7x minus 2. I can't simplify this anymore. So this is f over g of x. But I've got to limit my domain here. My domain here is no longer all real numbers because I have 7x minus 2 in the denominator. So because I've got a variable in the denominator, I have to set that equal to 0. So I have 7x equals 2. Divide both sides by 7. Okay, and so x cannot be 2/7 because when x is 2/7, that makes my denominator 0. And so I have to write that in interval notation. So I have negative infinity to 2/7 parentheses union 2/7 to positive infinity. So the only time that we have to worry about limiting our domain is when we have a variable in the denominator or we have a variable inside the square root symbol. And that's what you look out for in these problems. Okay, let's move on to number 22. Number 22 is compositions of functions. It says if f of x is 5 minus 3x and g of x is 2x squared plus 6x, find f composed of g of x and g composed of f of x. So for the first one, what we are going to do is we are going to take our g of x function and we are going to put it in for the x value in our f of x function. So this is f of g of x. Okay, so we are plugging 2x squared plus 6x in for this x right here. So I have 5 minus 3, and instead of x, I'm going to write everything that's g of x. So I have 2x squared plus 6x. And now I need to simplify that. And we need to be careful here because we are simplifying by distributing that negative 3. So don't forget the negative. So I have 5 minus 6x squared. Then I have negative 3 times 6x. So I've got negative 18x. So traditionally, your variables are written in descending degree. So I have negative 6x squared minus 18x plus 5. It doesn't make it wrong if you don't put them in descending order, your exponents. That's just traditionally how it is. Now, part 2 reads g composed of f of x. So this time we are going to take f of x and we are going to plug it in for my x over here. So this is g of f of x. Okay? So wherever there's an x, I'm going to put 5 minus 3x. So I have 2 times 5 minus 3x squared plus 6 times 5 minus 3x. Okay? And what we need to do now is we need to take our 5 minus 3x, and I'm going to do it down here off to the side. I need to do 5 minus 3x times 5 minus 3x, and I'm going to FOIL that. 5 times 5 is 25. 5 times negative 3x is negative 15x. Negative 3x times 5 is negative 15x. Negative 3x times negative 3x is plus 9x squared. Now I'm going to rewrite this in descending order. So I have 9x squared. Then I have minus 30x plus 25. So I just reordered that while I was combining like terms. Now I plug that back in for my 5 minus 3x squared. So I have 2 times 9x squared minus 30x plus 25. Now, during my next step, I'm going to distribute. 2 times 9x squared is 18x squared. 2 times negative 30x is negative 60x. 2 times 25 is going to be 50. Now I'm distributing a 6. 6 times 5 is 30. 6 times negative 3x is negative 18x. Okay? Now I'm combining like terms. So I keep my 18x squared because there's no other x squared. Then I have negative 60x and negative 18x. That gives me negative 78x. Then I have 50 plus 30, which gives me 80. So g composed of f of x is 18x squared minus 78x plus 80. Okay. Now, for number 23, we did not talk a lot about this in number 23, but what this problem is asking us is we are going to use composition of functions to determine if these two functions are inverses of each other. And the way that we determine if these two are inverses of each other is once we simplify. So we can do f composed of g, we can do f composed of g of x, or we can do g composed of f of x. Either one, doesn't matter which one we do. If these two functions are inverses of each other, we are left with x. If we are not left with anything other, if we're left with anything other than x, that means that these two are not inverses of each other. So it doesn't really matter which way we do, if we do f composed of g or if we do g composed of f. If they're inverses of each other, we will, when we simplify everything out, we will be left with f. So I'm going to go ahead and do f composed of g of x is what I'm going to do. So we're going to take g of x and we're going to plug it in for this x right here. Okay, so I have 5, and let's change that color so that we can really see what we're doing. So I'm going to plug in for x, negative 4x plus 9 over 5. And then I've got plus 4 over 9. Okay, Now, as I simplify this, and let's simplify this using green, this is 5 over 1 right here. So I can actually mark these two out, and then I'm dealing with much easier numbers. So I have negative 4x plus 9 plus 4 over 9. Okay? And when I do that, I end up with negative 4x plus 13 over 9. And I can't simplify that anymore. So I did not get just x. So that means that these are not inverse functions. So not inverse functions is what that means. Okay. Now, for number 24, we are finding the inverse of these two functions. So let's look at these. Whoops. So here's the first one. In the directions say, find the inverse of the given function if it exists. And so I think the first thing that we have to do is we have to determine if this is a one-to-one function. And this particular function right here is a one-to-one function because it's a line. And the way that we know that is because x is raised to the first power. There's no x squared, there's no x cubed or anything like that. So we are able to determine that this is a one-to-one function. Because it's a one-to-one function, we can find its inverse. And so the first thing I'm going to do is I'm going to take my f of x and I'm going to make it a y. So I'm going to have y equals negative 3x plus 5 over 2 plus 1. The next thing that I do is I switch my x and y. So I'm going to have x equals negative 3y plus 5 over 2 plus 1. And now at this point, I am going to solve for y. Now, you may want to multiply that 2 to get rid of that 2 to begin with. And that is a reasonable thing to do. You can just multiply everything here by 2 to get rid of it. The other thing that you could do is you could subtract 1 from each side. And that's what I'm going to do. I'm going to go ahead and subtract 1 from each side. And I'm going to be left with x minus 1 equals negative 3y plus 5 over 2. Okay? Now I'm going to multiply 2 by both sides, and I can get rid of this here, but the thing you've got to do is over here, you've got to multiply it all by 2. So what I'm left with now is 2x minus 2 equals negative 3y plus 5. And I am going to take this and I'm going to rewrite it up here just so we can do the algebra. So I have 2x minus 2 equals negative 3y plus 5. Okay, my next step then is to subtract 5 from both sides. So I have 2x minus 7 equals negative 3y. Okay, and now I am going to divide by negative 3. Okay. And I'm dividing both sides by negative 3. So I have 2x minus 7 over negative 3 equals y. Now, it's possible that you may have moved that negative to the numerator. I probably wouldn't. I would leave it just like this, but it's possible that you would have taken this negative right here and then just kind of distributed it to the numerator. And so you might have negative 2x plus 7 over 3 equals y. I tend to leave it like this, okay? But I do want you to realize that both of these things mean the same thing. So our final answer is f inverse of x equals 2x minus 7 over negative 3. But if you have f inverse of x equals negative 2x plus 7 over 3, I want you to realize that's the same thing, okay? So our original function is f of x equals negative 2x plus 5 over 2 plus 1. And our inverse function is negative 2x minus 7 over negative 3. Okay, and our last problem of the day, we have to determine, first the thing that we have to do is we have to determine if this is a one-to-one function. This is a parabola, and so if I graphed a parabola, and this is just a sketch of a parabola, but it would look like this, okay? And a parabola is not a one-to-one function. So you have to be very, very careful because the directions to this say, find the inverse of the given function. There is an inverse of this, but the inverse is not a function. So if your direction said y equals 4 times x plus 1 squared minus 5, what's the inverse? Then you could find the inverse. The issue is that the inverse of this is not a function. This is not a one-to-one function. So when we find the inverse of it, we don't have a function. So the correct answer to this is not a one-to-one function, and therefore does not have an inverse function. But I do want you to understand, you can find an inverse, it's just not a function. So when we start getting nitpicky about our words, that's kind of what we fall into. Does not have an inverse function. And because this one fails the one-to-one test or the horizontal line test. Okay, so please let me know if you have any other questions, and I'm happy to help any way that I can.